Hi everybody and welcome. Today we're going to be talking about similar polygons. So your goal after watching this video will be able to recognize and also solve problems that relate to similar polygons. So let's think of first the real world example of this. So I had my wife take this picture of me. This is in New York City. And when I think of similar figures and similar polygons, I think of those little scale model replicas you can buy. So in the background, we can see the big version here of the Empire State Building. And actually, this is my hand, and right there is a scale factor replica. So everything about these two shapes is the same, in the same proportions. The towers are, the little, antenna signal on top is exactly the same proportion as it is to the height of the building. The only difference is it's smaller. I think if you've ever seen the movie like Ant-Man, they have those, like that small building he puts in a briefcase and then he makes it really large. That's kind of the idea. So if, they have that technology, they could make the Empire State Building figurine in my hand. If they could, make it as big, as tall as the real one that's in the background behind me, well, if they did that, then they would basically be the same in every single feature. So that's the idea of similar polygons is, they're different sizes, but other than being a different size, everything else about them is basically the same. So let's formalize this definition here. So similar polygons is our word. And this is when we have something that is the same shape, but not necessarily the same size. So an example, we could have triangle ABC, and we could have triangle DEF, and we could say that they're similar because their angles are the same. So ABC is similar. That's the symbol for similar. It's a little squiggly line. And based off of this, we could say things like, angle A is congruent to angle D, matching up those corresponding sides like that. But the sides aren't exactly the same length, but they're in a constant ratio. So, maybe if this is 4, 4, and 2, and this was 2, 2, and 1, we know that a 4 to 2 ratio is the same thing as a 2 to 1 ratio, right? So they're in a constant proportion. So we can use that to solve questions. So, you could do something like 4 over 2 equals 2 over 1 from the different triangles. And if you do that, you're going to see they're equal, right? So if you divide that out, 4 divided by 2 is 2, 2 divided by 1 is 2. So again, that constant proportion, it does work. Questions like that we'll be able to solve. So let's actually jump into some of those questions that we're going to be expected to solve. So first things first, for example number 1, are they similar? So the sides being exactly the same, they don't have to be the same measurement, but they do have to be in a constant proportion. And we also know that our angles need to be exactly the same. So first things first, angle B and angle S, that works out for us. But we don't know these two missing angles here. So for our first one, we have to solve for that. So 80 plus 60 plus x equals 180, or 140 plus x equals 180. Subtract 140 from both sides. Get x equals 40. So we know that this here is 40. So it looks like they have two angles that are the same. So if they have two angles that are the same, let's just double check here for that last one. 80 plus 40 plus x equals 180. 120 plus x equals 180. Subtract 120 from both sides, and x equals 60. So it looks like we're in good shape. All three angles are the same. Let's double check our ratio though. So let's say maybe we do something like this side to this side, and this side to this side. Let's make sure that they're proportional. So 5.2 over 8. That should equal for us 3.9 over 6. And let's check that in our calculator. So 5.2 divided by 8 gets us 0.65. And let's see if 3.9 divided by 6 conveniently also gets us 0.65. So we can say angles are the same, or they're congruent. The sides are proportional. So they are similar. And that's what we want to do. So again, we got to prove all those properties, but once we do, we'll be in good shape. Let me rewrite that line here. So they're similar figures, and even to be more specific here, practice writing out those statements. So triangle ABC is similar to triangle RST. And we're in good shape. All right. Next, when we have similar figures and we want to know just how much smaller, just how much bigger another one is, we use something called a scale factor. And this is just a numerical ratio when comparing the lengths of corresponding sides of similar figures. So an example of this, you have like another scale model. So this isn't quite my Empire State Building example, but it's basically you have a toy car and you have a real car. So the toy car is 22 inches. And the real car is 14 2/3 feet. Well, that's basically our scale factor. The only rule for scale factor is that we do have to simplify this to be over 1. So for every 1 foot of real car, we're going to see 1.5 inches of our model car. The way that we got to 1.5 over 1 is we just divided 22 divided by 14 2/3, or 22 divided by 14.6 repeating. And when you do that, you'll get an exact answer of 1.5. So for every 1.5 inches of scale car, we have 1 foot of a real car, and that's our scale factor. This is just relating the sizes of these things to each other. All right, last question here to work through today is our third example. 2 polygons are similar. So first, write a statement. So again, we got to match these up. So angle 1, 2, 3, 4, and 5 to angle 1, 2, 3, 4, and 5. So we'll say pentagon ABCDE is similar to pentagon, and again, got to match up A, which is angle 1, with angle 1 over here, which is R, and then keep going, STUV. Second, they want us to solve for our x value and solve for our y value. So we want to use a proportion here. So, we could use like x is this side, and then in green, we'll have that side. So we can set up our blue to our green proportion. So x over 6 is equal to 3 over 4. And once we do this, we can use the skill from last video, cross multiply, and then divide it out. So here we would get 4x equals 18, divide both sides by 4, and x equals 18 over 4. Okay, so there's 1. We do the exact same thing to solve for y, and I'll leave you the space to do that. And then finally, we want to find that scale factor. So once you have these sides solve for each other, we can even just take these green sides here. We can say our bigger figure over our smaller figure, and again, divide 6 by 4, we'll just get 1.5 from our bigger figure to 1 on our smaller figure, and that is our scale factor. Just rating 2 proportional sides basically divided by each other or in relation to each other. And if we do that, we'll be in good shape, and we'll have solved here. All right, as always, any questions, please let me know. Please finish up the remaining questions, all the parts of this video that we did not finish in those notes. That's your job to complete now. And again, like I said before, questions, please reach out. We are here to help, and I'll see you all in Teams very soon.